Yes, today we have another section of electrolysis. These sections talk about electrolysis of aqueous sodium chloride and dilute sulfuric acid. Okay, now let's take a look at the first part of it, which is the electrolysis of aqueous sodium chloride. Aqueous means what? When you say aqueous, what do you mean? When you say something is in aqueous state, what do you mean? It's not concentrated, it's not specifically dilute. It could be in molten or in solution form, okay? So when we say aqueous sodium chloride, meaning sodium chloride probably dissolved, okay? Probably dissolved in water. Are you with me? So it means sodium chloride that is probably dissolved in water. So let's take a look at that first part, aqueous sodium chloride. So let's take a look at that electrolysis. If you're talking about that electrolysis, it's like you're saying water H2O, okay, H2O plus what? Sodium chloride, NaCl. So you have a solution. Now this solution will ionize when you pass electricity through it. So when you pass electricity through it, you have OH ion, you have OH minus ion, you have H ion, that's the hydrogen ion, the positive ion, you have the sodium positive ion, and then you have the chlorine negative ion. So you have in the electrolyte, when you pass electricity through it, which I'm going to show you from the diagram, when you pass electricity through it, you're going to have about 4 different ions. The hydroxide ion, OH ion, the hydrogen ion, which is the proton ion. You have the sodium ion, the Na plus ion, and then you have chlorine minus ion. So these ions will be present in the electrolyte if you pass electricity through it. So you know, electrolysis is simply the decomposition of an electrolyte by the passage of an electricity through it. So that's what electrolysis is. Electrolysis is simply using electricity to break the compound into ions, The compound in this case is the electrolyte. You're going to break it to ion. We're going to see that from this diagram. Take a look at the diagram. You have this solution, the aqueous sodium chloride, and then these are electrodes. These are electrodes which could be graphite, which could be carbon, which could be platinum, okay, as electrolyte. As electrodes, and then they are connected to batteries. You can see the positive, the negative. So the positive side is the anode, and the negative side is the cathode. The negative side is the cathode. So when this is connected to a battery, that's why you see plus, minus indicated in this place. Okay, normally you can draw it like using proper battery or use it battery symbols to symbolize this, to show this. So, however, the point to make is that once this is done, you know, electron can flow and charge can flow. So the electron flow from the cathode into this solution. Now, when that happens, it will ionize to break this compound into ions. These ions, I have itemized them. I say you have the hydrogen plus ion, the chlorine ion. Those one will migrate to the negative. The positive ion will migrate towards the positive, and the negative ion will migrate towards the negative. The negative ion will migrate towards the positive anode, while the negative ion will migrate towards the positive. The negative ions will migrate to the positive anode. The positive ion will migrate towards the negative cathode. So we're going to look at that. We're going to explain that. But before then, let's take a look at the basic elementary foundations of this concept. Now, brine is a concentrated solution of aqueous sodium chloride. When we say brine, the word brine is a concentrated solution of what? Of sodium chloride. Sodium chloride, NaCl. That's symbol of sodium chloride, salt. Okay, your table salt. Now, it can be electrolyzed using inert electrodes. Either you use platinum or carbon or graphite. Carbon graphite, you know, graphite is an allotrope of carbon. So you can either use carbon as a name or you specifically mention graphite. Now, when electrolyzed, it will produce bubbles of gases at both electrodes, whether at the cathode or at the anode. Why? Because hydrogen ions will migrate. You know, hydrogen ions, they are positive ions. They will migrate towards the cathode. Cathode is a negative electrode. They will migrate towards the cathode. These hydrogen ions will come towards the cathode, the negative electrode. They will migrate towards the cathode, this negative electrode. All hydrogens will line up here. They will line up here. All the hydrogen ions will line up here. Okay? Then all the chlorine ion, we will tell you why. Why is it hydrogen? Why not sodium? Okay? If you look at the reactivity series, I think I explained this in one of the other sections we had before. Sodium is more reactive in the reactivity series than hydrogen. Sodium is more reactive, so it's like the big brother, it's like the senior brother. So if we tell, it's like sending the junior one to go on an air ride. So we allow hydrogen to go on his behalf. Okay, so hydrogen will line up here. Then for halides, if you have other ions and halides, the halides will migrate. Okay, like sodium chloride is a halide. A halide is a metal and a halogen. A halide is a metal, a solution, a compound of metal and a halogen, like barium chloride, like sodium chloride. Not only chloride, like any solution with bromide, potassium bromide. Okay, any of the halogen. Remember the halogen, the group 7 in the periodic table. They are called the halogen. Fluorine, but fluorine is too explosive, so sometimes we don't even consider it when we are writing chemical reaction. Fluorine, chlorine, bromine, iodine, and astatine. These are the group 7 elements in the periodic tables. They are not metals, but they form what we call the halides. The name halides comes from their halogen as their name. Their family name is halogen. Are you with me?
Yeah.
Okay, now let's quickly take a look at this. So we say when electrolysis produces bubbles of gases at both ends, which gas will be at the anode and which gas will be found at the cathode when you do this? Okay, the gas that will be at the cathode will be hydrogen gas. The gas that will be at the anode will be chlorine gas. Right? Okay. Why? Because the hydrogen has positive ions. Hydrogen have positive, so they will migrate to the negative electrode. Cathode is a negative electrode, so they will migrate to the negative electrode. Why chlorine has a negative ion, so they will migrate to a positive electrode. So it's vice versa. It's like the law of electric charge. The positive attract negative, negative attract positive. But positive, they repel each other. Okay? So same here. The positive ion will migrate to negative electrode. And what makes electrode to be positive or negative? Because if you take a graphite, it doesn't just become positive or negative. If you take carbon as your electrode, it doesn't just become positive or negative. If you take platinum, it doesn't just become positive or negative. I think we said this previously, that if a electrode is connected to positive terminal of the battery, that electrode will be the positive. If an electrode is connected to a negative terminal of the battery, that electrode will be negative. Is that okay? So
yes.
So we say they will produce hydrogen gas and chlorine gas, and then they will leave behind. Remember, there are two things that didn't migrate. Two things from the ionic solution in the electrolyte that did not migrate to the anode and cathode. Remember that. What are those two things? Sodium ion and hydrazine ion. Sodium ion and hydrazine ion. OH ion and Na plus ion. OH minus and so these two that's remaining will react together to form what? Sodium hydroxide. They will join together to form sodium hydroxide, which is a solution, which is an alkali. So meaning an alkali is produced. So meaning in the electrolysis of Bri or aqueous sodium chloride, you will have hydrogen gas produced, you have chlorine gas produced, and you have an alkali, sodium hydroxide produced. So three things will be produced. Normally, in many cases, only two products we normally get. One in the anode, one in the cathode. But in this particular reaction, or electrolysis, three things are produced. The hydrogen gas, the chlorine gas, and the sodium hydroxide is also produced. So we say this substance all have important industrial uses. Like for example, what do we use chlorine for? Chlorine is used for bleaching. If you want to bleach your clothes or bleach your skin or bleach anything bleaching, like oil stain on your clothes, you can use chlorine to remove it, right? Then hydrogen is used to make margarine. When you're making margarine, the one you call margarine or butter, we use hydrogen to make them. Hydrogen is used for making margarine. Then the other third product that is made, sodium hydroxide, is used to make soap and detergent. We use sodium hydroxide for making what? Soap and detergent. So we say hydrogen that is produced is used to make margarine. Hydrogen is used to make margarine. Please take note. These things are easy. Then chlorine is used for bleaching. Chlorine is used for bleaching. And sodium hydroxide is used for making soap and detergent. Soap for making soap and detergent. Is that okay?
Yes.
Now let's take a look at the product at the negative electrode. That's negative electrode is the cathode. So let's take a look. You know what is found in the cathode is the hydrogen ion. The hydrogen ions are discharged at the cathode. They migrate. When electricity is passed through the electrolyte is the water aqueous sodium chloride. The aqueous sodium chloride. Okay? Aqueous sodium chloride. This one you see this color. This is it green color?
Yeah.
Yeah. So this green color that is represented is the aqueous sodium chloride. So this one, when electricity passes through it, it will break this aqueous sodium chloride into ions. These ions are four in this regard, or according to this concept. There are four. One is sodium ion, Na+. This one you see this yellowish or orange color, Na+. This is one of the ions that will be dissociated. That will be discretely discharged from this compound, from this aqueous solution. Then another ion that is produced is hydrogen ion. You see, H+. This is another ion that is produced when electricity passes through the compound, this aqueous sodium chloride. Another ion that is produced is chlorine ion. This Cl- is another ion that is produced, this green color. Then another ion that is produced is OH-, hydrogen ion, this reddish color. So these are the ions that are produced. But because hydrogen is less reactive in the reactivity series, it is the one that will migrate. If you see the arrow, there are small arrows showing that the hydrogen migrates. They will migrate to come and stay here, to stay around this electrode. They will migrate from the solution, they will come and stay here around. All these ones you see, these big ones, they are the hydrogen ions. They are the hydrogen ions. Are you with me? Yeah, brighter. They are the hydrogen ions. These big ones, they are the hydrogen ions. They migrate. See this hydrogen ion, you see they have an arrow showing that they are moving. They are going to move towards this place. So they've moved. The hydrogen ion moved this. They surround this negative electrode. There, on the other hand, this way, you see the chlorine, they are the one that have the arrow, the chlorine ion, the negative ion. Not the OH. The OH will not move. It's the chlorine one. Whenever we have halides, it is that halide that will move. If it's chlorine will move. If it's bromine will move. If it's iodine will move. So whenever you have halide, the halogens, metal and halogen, that's what will move, that will replace the OH ion. So this one will move to this place. These big ones. Okay, there are less other ions, but they are not so significant. They are not so significant. Then the remaining sodium that did not migrate here, the sodium did not migrate. Hydrogen positive ion is the one that migrates. The sodium positive ion will fall back to this solution. And then the OH hydrogen ion that did not migrate here will also fall back to this solution. Then they will react together. Sodium and this OH, this Na here, and this OH, this orange Na, and this OH hydrogen ion, they will now react together to form sodium hydroxide. This sodium hydroxide, one of the uses industrially is to use it to make what? Soap and detergent. We use this sodium hydroxide to make soap and detergent. We collect the chlorine for bleaching. Not only bleaching we use chlorine for, we can use it to do chlorination, to purify drinking water. We add a little bit of it to kill germs and bacteria. Okay, the clean water you drink, the drinking water you take, a little portion of chlorine is being added to it to kill germs. Okay, so the hydrogen is used for making margarine. Not only margarine, we also use hydrogen to make other things, right? So this is the product of this electrolysis. But then again, let's take a look at what we have here. The same hydrogen ion gained electrons to form hydrogen gas. How do they gain electron? Hydrogen ions here. They gain electron because electron will migrate from this negative side of the battery towards this place. Electron will move these ones. They will move these small ones. Electrons will move here, and then the hydrogen will gain them. Electron will come and they will gain electrons. So the equation at the cathode is hydrogen ion, H plus ion. We're going to see those equations. H plus ion plus 2 electron. You put 2 at the back of H, and then plus 2 electron will be equal to H2 hydrogen gas. We produce hydrogen gas. So when they gain electron, when hydrogen ion gain electrons, they will become hydrogen gas. So that's how the hydrogen gas is produced here, and it bubbles. So it can be collected through this place. So for the hydrogen to be produced is because the hydrogen is produced because the hydrogen ion gain electrons. The hydrogen ions are the cathode, they gain electrons, and then they become hydrogen gas. Now, it continues, the electron continues because it had to go this way. So here, this place, the chlorine ion, they lose electrons because they already have electron from here. So they will lose the electrons, and then they will become chlorine gas. Here they don't gain electron; they lose electron to become chlorine gas. Is that okay? They lose the electron. The electron will now flow back. This chlorine already have the electrons. The electron will flow back. Remember, they have negative ions. So they will lose electron, and the electron will flow back to the battery, and then the process continues. So here, hydrogen ion gain electron to become hydrogen gas. There at the anode, the chlorine lose electrons to become chlorine gas. Then, like we said, sodium hydroxide is produced that is never used. Okay, so this is the electrolysis of Bri. This is the diagram. Then this is the cathode. The anode, the positive electrode. At the positive electrode, the chlorine ions, they are discharged at the anode. They lose electrons and form chlorine gas, right? So this sodium ion and the hydrogen ions, they remain behind, and then they form sodium hydroxide solution. They remain behind in this place, and then they form sodium hydroxide solution. So that's the electrolysis of this. Is that understood?
Yes. Pardon me, but I need to.
Okay, now let's take a look at dilute sulfuric acid. Let's quickly take a look at that. Okay, we say dilute sulfuric acid. Let's take a look at the electrolysis of dilute sulfuric acid. What happens at the anode, what happens at the cathode. Even if we don't draw the diagram, we already have a complete concept, right?
Yeah.
We already have a complete concept. Now let's quickly take a look at that. The first section is to look at the dilute itself. Dilute sulfuric acid can be electrolyzed using inert electrodes made from either platinum or carbon or graphite. You can use any of this one that we've specifically or often talked about as your electrode. You can use graphite electrode, you can use carbon electrode, you can use platinum electrode. Okay, that's the first thing the concept we've got it. Then when you do that, you know sulfuric acid is H2SO4. Sulfuric acid is H2SO4. So what happens if you electrolyze it? It will break it to what? It will break it to hydrogen ions, right? Hydrogen ions, and it will break it to hydrogen ions, and which other ion? OH ion, right? Because in this case we have OH ion. We also have what we call OH ion. Remember here there's no halide. Sulfuric acid, there's no halide. It's hydrogen and sulfate. There's no halide. So the water, you know, it's dilute, so there's water. The water ionizes to hydrogen plus and OH minus. Right? Now let's take a look at what we have. We said the bubbles of gas are still at both electrodes. Now let's find out which gas is produced at the cathode and which gas is produced at the anode. Product at the negative electrode, which is the cathode. Let's take a look at it. First of all, the hydrogen ion, you know, H2SO4, when you dissociate it, dilute one, you have hydrogen ion, SO4 2 minus ion, and then you have OH ion, and so on and so forth. Now when that happens, the hydrogen ion, which is H plus, we migrate to the cathode, the negative electrode. The hydrogen ion, we migrate to the cathode, which is the negative electrode. We'll be attracted to the cathode. When I say migrate, meaning it's attracted there. You can use any of the terminology. Okay, so it will migrate to the cathode, and then they will gain electrons. You know, when they get to cathode, they always gain electrons. Okay, they gain electron, and then they will become what? Hydrogen gas. They gain electron, they become hydrogen. They will become hydrogen gas. Okay, this is the equation at the cathode. This is the equation at the cathode. Are you with me?
Yes.
Okay. I wish we can have something like to write, like not to write in the notebook. If we have, later we'll think about it. When I want to explain something, we should have look for a screen, download a screen where someone can be writing. So I can always switch. When I want to write, I switch between the PowerPoint and the place I'm writing on. Is that okay? Okay.
No, the mic is still off, right?
Okay, now let's take the next stage. Let's move to the next stage. Then we say the product at the positive electrode, the OH minus ions, they will be attracted or they will migrate to the anode. You know, when they migrate to the anode, they will lose electron. At the anode, the OH will lose electron. Okay, they will lose electrons and form oxygen gas and water. They will lose electron and form oxygen gas and water. They will form oxygen gas and water. Okay, so the equation is shown. We will. I know here they're not showing the equation. I think most of the time we have a section for half equations. I think it's the next section. So where we demonstrate half equations of most of the electrolysis that we described. We have a section where we'll be showing the half equations. Now let's move on quickly. Determine what gas is produced. If the gas produced, now sometimes, you know, when the gas is produced, you don't know what gas is produced. So you have to carry out some tests, right? most of the time, when gas is produced, because you don't know, you don't just know, you're just mixing chemical and you just see something's happening. You know a gas is produced. Some of them bubbles off. You know a gas is produced. Now this gas, you can put them in a test tube and test whether they are oxygen gas, whether they are hydrogen gas, whether they are carbon dioxide gas, whatever gas that is being produced, you can test. You know there are basic tests for all of this. Now if the gas produced at the anode relights a glowing split, like if you take a matchbox, you light it up. If you bring it close to the gas and it makes it, maybe the matchstick that is about to go off, you see it rekindles it, relights a glowing split or rekindles a glowing split. It makes it burn more. Then it means that gas is an oxygen gas, right? Because oxygen support combustion. Oxygen supports combustion, right? So if it relights a glowing split, or it rekindles a glowing split that is deep into a sample of the gas, then the gas is oxygen. For example, look at the diagram. Okay, you bring a glowing split that is about to go off towards this test tube that contains the gas, a particular gas that is produced, whether in the anode or in the cathode. You just take the gas, you want to know what gas was produced. And then you saw that after you dip it, then it start burning like this, burning so conspicuously. It start burning so seriously, so intensely. Then you know that gas is oxygen. Then you know that the gas in this test tube is oxygen. Because oxygen outrightly, completely support combustion. Is that okay? Now what if we bring it towards it and the matchstick went off? You bring it here, the matchstick went off. So it means it's not oxygen. So we find another test. We do another test for it. So in this case, we want to test whether it's chlorine. Chlorine, we always bring a litmus paper. Okay, maybe a blue litmus paper. So we take a blue litmus paper and bring it in here. Bring it in. You bring a blue litmus paper instead of bringing a matchstick, because you've tested, maybe the matchstick went off. Like twice, it went off. So you already concluded this gas obviously is not oxygen. So what then do? You bring another test parameter. What is that test parameter? You bring a blue litmus paper, a damp one. You make it damp, like make it wet. So when we say damp, it's a bit wet. So you bring a damp blue litmus paper. What happens if it's a chlorine gas is that it will bleach it. If you bring a damp litmus paper to this gas here, and if the gas is chlorine, it's going to bleach it from blue to red to white. Eventually it will bleach it to take out the color, the red or the blue. First of all, if you bring it close, it will be changing to red, and at some point it will outrightly see that it's bleached. It's bleaching the color away. So when that happens, means the gas here is what? Chlorine. The gas here is chlorine. So chlorine eventually changes the blue litmus paper to red, then eventually to white. It bleaches it to white. You can see the lower segment is changing to white. And if you leave it more, everything will eventually turn to white. If you leave it for a longer time or dip it more, everything, it will bleach the whole damp litmus paper and change it to white. Is that okay? Sorry for this picture. They are advert picture. Okay, they're Yungu. These people are Yungu. Let's move up quickly. Okay. Now what if the gas you tested it is not chlorine, it's not bleaching a damp litmus paper, it does not support a glowing split, and you bring a damp blue litmus paper, it doesn't bleach it, it doesn't change the color, nothing happens, then you still have to test for one more gas. Which is the gas that is normally and quickly found at the cathode. So you have to test for this gas. Now, if the gas produced at the cathode burns with a pop sound, like you bring a glowing split to it, you make boom, makes a pop sound. It makes a sound. Boom, boom. It makes such sound. When you bring a glowing, like you take a match stick, and you bring it towards the test tube, and it makes sound, then the gas is hydrogen gas. Okay, when it makes a pop sound, then when the sample is that is lit with a lighter split, then the gas that is found in the test tube is hydrogen gas. Okay, let's go to the next section. We finished this section. Let's see. Let's take a look at electrolysis of aqueous solutions. Let's take a look at electrolysis of aqueous solutions. Okay, this is more for extended students, for the Cambridge IGCSE extended students. So, aqueous solution will always have water present, right? Aqueous solution will always have water present, H2O. That's why they are called aqueous, right? There is water in them, in that solution. There is water in that solution. So when you say aqueous solution, meaning there is water, and water dissociates. When you bring electricity to it, it will dissociate into hydrogen ion reversibly. Water will dissociate to hydrogen ion and hydrogen ion. So it will break into two ions, the proto ions, the hydrogen H plus OH ion, OH minus. So the water ion always dissociate into these two, and this will only happen when the water molecule dissociate to hydrogen ion, that's H plus and OH minus, when you bring electricity to it. Okay, these ions are also involved in the process, and their chemistry must be considered when you study electrolysis. Just like in the electrolysis of Bry, we say the hydrogen here, the H plus will move to the cathode, but the chlorine from the sodium chloride will move to the anode. So when we're doing electrolysis, we must consider this aqueous or dilute case, meaning there's presence of water. So we now have an electrolyte that contains ions from the compound plus ions from the water. Whenever, like when we did for brine, when we did electrolysis of brine, so you have electrolyte that contains ion from the compound itself, like you're looking at, H2SO4, the one we looked at just now. Then and that of brine, sodium chloride, okay, aqueous sodium chloride. Then you'll be looking at the ions from the sodium chloride, which is sodium Na plus, chlorine minus, and then you'll be looking at the ion from the water also, H plus, OH minus. Okay, so whenever we have aqueous solutions or we have dilute solutions, we'll be looking at considering the H plus ions, these ones, the H plus ions, and the OH minus ions. H plus ions and the OH minus ions. Is that okay? Okay. Now we know we also try to figure out which ions get discharged and at which electrodes depends on the relative reactivity of the elements involved. We find out which ions will be discharged, which one will migrate to the cathode and which one will migrate to the anode. That's the next concept, what you need to know. And then this is based on the relative reactivities of the elements that are involved. Remember when I said that hydrogen is less reactive to sodium, so it replaces sodium, migrates to the cathode instead of sodium. Then I say whenever there is in the anode, when you have halides, the halides will move instead of any other negative ions. The halides will migrate instead of any other negative ion. But when you have sulfate, carbonate, and this, then the OH ion will move to form water and oxygen in the anode. The OH ions will move to form water and oxygen gas in the anode. So that's that for that. Now let's take a look at concentrated and dilute solutions of the same compound gives different product. Yes. Why? Because concentrated solution, you're only looking at the ions from the compound. But when you're talking about dilute solution, you're looking at the ions from the compound itself and also ion from the water. That's these ones. You also have to consider ions from the water, the H plus ion and the OH negative ions. So meaning in this case you'll be considering 4 ions. Maybe 2 ions from the compound, the electrolyte, the compound, the electrolyte itself, and then 2 ions from the water. So the what you get from concentrated and dilute, they're different. For concentrated solution, you only get the ions from the compound. From dilute solution, you get the ion from the compound plus the ion from the water. So that's why the products they give that are different. For anions, anions are negative ions and cations are positive ions. For anions, the more concentrated ions, we tend to get discharge over a more dilute ions. The more concentrated one, we get discharge. That's we migrate. Okay, we migrate to the positive electrode. Okay, now let's take a look at the positive electrode. The ions that normally migrate to the positive electrode. Remember, the positive electrodes are called the anode. They are called the anode. Now, it's only negative electrode that migrates to the positive electrode. Remember, only negative ions like OH ions, okay? Negatively charged ions, like OH ions and non-metal ions are attracted to the positive electrode. Okay, because the anode is a positive electrode. Only negatively charged ions will migrate to this positive electrode. If valence ions are present, like chlorine ion, bromine is part of it, but we don't use bromine because bromine is explosive, it's very reactive, it's too explosive. So normally we start consideration from chlorine, bromine, iodine. Okay, if halides ions are there, like the chlorine minus ions, the bromine minus ion, and the iodine minus ion, these ones are called the halides. Okay, and the OH ions are present, then the halides ion will be discharged. So whenever you have chlorine ion versus OH ion, which one will migrate? Which one will migrate to the positive electrode? It is the halides that will migrate. I already explained this concept. The halides will migrate instead of the OH ion. Is that okay? The halides ions like the chlorine ion. So anytime you have electrolysis of, let's say electrolysis of multi-lead bromide, okay? Whenever you have electrolysis, just like the one we have for sodium, brine, sodium chloride, we also have the OH ion, right? We have the chlorine negative ion. It was the chlorine that migrated, that got discharged. Okay, why? Because the halides will displace the OH ion. So the halides will be discharged at the anode, they will lose electrons and they will form a halogen. They will form the halogen. If it's chlorine ion, it will form chlorine gas. If it's bromine ion, it will form bromine gas. If it when they lose electron at the anode. If it's iodine ion, it will form iodine gas. It will form an iodine. So if no halides are present, then OH it will be discharged. If no halides, halides, chlorine ion, bromine ion, iodine ions. If these ones are not present, then the OH ion will be discharged at the anode and they will lose electrons to form oxygen gas. They will form oxygen gas and water. Okay? They will lose electron to form oxygen gas. In both cases, the other negative ion remain in solution. The other negative ions remain in solution. Okay, and let's move on. Sorry for that interruption. We say if no halides are present, then the OH ion will be discharged. Okay. Now, in both cases, the other negative ion remains in solution. Right? In both cases, the other negative ions, they will remain in solution. If there's any other negative ion, they will remain in solution. Now, if a concentrated halide solution is being electrolyzed, if a concentrated halide solution is being electrolyzed, then the hydrogen forms at the anode. Now, if the dilute halide solution is being electrolyzed, oxygen form at the anode. You need to take note of these two concepts. If it's a concentrated halide solution that you are like concentrated sodium chloride, not dilute one. Then, if it's a concentrated, the halogen forms at the anode. The halogen could be the chlorine, the chlorine gas, the bromine gas, the iodic gas. Then, if it's a dilute halide solution that is being electrolyzed, oxygen is formed at the anode. We're going to see an example now so that we can get this clear or clearer. For example, for the concentrated solution of barium chloride, a concentrated solution of barium chloride. So this chlorine ion will be discharged at the anode, right? Will be readily discharged instead of the OH, right? So chlorine gas will be produced at the anode. But if the solution of dilute, however, only this one OH ion will be discharged, so oxygen will be formed. So if it's a dilute solution, OH, this one will be discharged, not the chlorine will be discharged. Okay? If the solution is dilute, then this OH will be discharged. Once OH is discharged, obviously oxygen gas will be produced. Is that okay? If it's a concentrated solution, the halide will be discharged, the chlorine. The chlorine gas will be produced. If it's a dilute solution, OH will be discharged, and then oxygen gas will be produced. Now let's take a look at what happens at the negative electrode, the cathode. Cathode, the hydrogen ion and metal ions are always attracted to the negative electrode, to the negative cathode. The hydrogen and any metallic ion, like sodium ion, potassium ion, calcium ion, all the metallic ions and the hydrogen, they are the ones that are attracted to the negative electrode, which is called the cathode. They are the ones that are attracted to the negative electrode, which is called the cathode. Okay? Now, either hydrogen gas or metal will be produced. Since these are the only two, is either a metal is produced or hydrogen gas is produced. Okay? Now, when is hydrogen gas produced? When the metal above it, they are higher than hydrogen in reactivity series. The hydrogen will migrate to the. But if the metals are below hydrogen, those metals will migrate in the reactivity series. So you have to look up reactivity series of metals. Okay? We have to look up the reactivities of metals. I think copper is below hydrogen. Copper is below hydrogen and. Yeah, we have to look up the reactivity series so that it's easy for us to know which one will migrate, which one will remain. Which one migrates, which one remains. Okay, I have one here.
Okay.
Okay, if you look at the reactivity series, like I said, copper is below hydrogen. And silver, copper and silver they are below hydrogen. So whenever, like silver chloride or silver bromide, then it is silver that will migrate, not hydrogen, because it's below hydrogen in the reactivity series. Remember the one that is less in the reactivity series, comparing the metal with hydrogen, it is either hydrogen migrate to the cathode. Is either hydrogen migrates to the cathode or a metal migrates to the cathode. I said if the metal is below hydrogen in the reactivity series, the metal will be the one that will migrate. But if the metal is above hydrogen in the reactivity series, hydrogen is the one that will migrate. Is that okay? Yes. So we say if a metal is above hydrogen in the reactivity series, then hydrogen will be produced and a bubbly gas will be seen at the cathode, right? This is because the ions are more reactive metal. The ions of the more reactive metals will remain in the solution. The ions of more reactive metal. So if the metal is more reactive than hydrogen, the ions will remain in the solution. They will not migrate. Okay? You know, I use literal sense to explain it. I say, oh, he sent this junior brother. That's just a literal meaning. Okay, but the real scientific meaning or reason is that the ions that are more reactive, they will remain in the solution, right? And they will leave the weaker one to migrate. It's just like what is happening in countries. In most of the time, the people who are poorer or who are looking for better life, they are the ones that migrate and go to other countries for better life. But people who are super doing well in a given country, who are well established, they only travel and come back. They don't migrate. Okay? That's what this concept represents. Like the ions that are more reactive will remain in the solution, causing the ions of the least reactive metal to be discharged or to migrate. So metals that are more reactive than hydrogen, they will remain in the solution, and then they will cause hydrogen to be discharged, to migrate to the cathode. Is that okay? So therefore, at the cathode, hydrogen gas will be produced unless the positive ion from the ionic compound are less reactive than hydrogen, unless the ions of the metals are less reactive than hydrogen. A good example of a metal, the positive ion of a metal that is less reactive than hydrogen is copper. Copper 2 ion is less reactive than hydrogen, and also silver. Silver ion Ag positive is also less reactive than hydrogen. So for these two metals, they will migrate instead of hydrogen. Is that okay? Is that okay? So here is the reactivity series. This one you need to comprehend. You need to what? Comprehend. You need to see. You need to have this in your notes. The most reactive metal is potassium, followed by sodium, followed by lithium, followed by calcium, magnesium, aluminum. Then there is carbon. Although carbon is not a metal, that's why it's written in red. But it joins in this regard. Okay. Then there is zinc. After zinc is iron. Then immediately iron is hydrogen. Hydrogen is not a metal, but because they produce positive ion, they put here. Okay. So hydrogen is in red. Then copper, silver, and gold. These ones are the least reactive metals. Hydrogen is even more reactive than them. So these are their symbols. On the right, on the left is the elements. On the right is the symbols of these elements. The most reactives are the ones on top, and the least reactives are the ones at the bottom. So you need to know this. If you don't know this, you've not started chemistry. Trust me, if you don't know this, you are not a chemistry student yet. You need to know this. You need to comprehend this, because it tells you many of the displacement reaction which you need this when you are writing chemical equations. You need to know which metal is more reactive. You need to know which metal is more reactive, which one can display which one, You need to know which one is more reactive and which one can display which one, so that it's easy for you to write a balanced chemical equation. Okay, now let's move on. Electrolysis of aqueous copper sulfate. Aqueous, you see, the word aqueous means not only the copper sulfate, not CuSO4, not only the copper sulfate, there will also be, since it's aqueous, there will also be hydrogen ion, water, you know, water, aqueous. There will also be hydrogen plus and OH minus. So there will be about four ions. So the copper sulfate will produce this ion, copper 2 plus ion, SO4 2 minus ion. So the copper sulfate itself is producing these two ions, the copper ion and the sulfate ion. And then because it's aqueous, remember we already explained this concept. Because it's aqueous, it will also produce what we call the hydrogen plus ion and the OH minus ion. It will also produce hydrogen plus ion and the OH minus ion. Are you with me? So now we're using the graphite electrodes. We're using the graphite electrodes. Look at them. Negative electrodes. These are the negative electrodes. And then we connect to a battery. You know, you can make the battery to be at the bottom or to be on top. It's okay, it doesn't matter. So you connect to battery. So battery flows here, dissociates this ion into 4. Now we have, because it's aqueous, we have 4 ions now. Now, which one will migrate to the anode? Which of these, to the cathode? Which of these positive ion? Copper ion or hydrogen ion? Which one will migrate to the cathode? Which one? Is it the copper ion? Is it the copper ion or the hydrogen ion? Which one will migrate to the cathode? Or which one will be discharged at the cathode? Yes? Copper ion or hydrogen ion, which one will be discharged? Which one will be discharged? Yes. You have to look at the reactivity series just now. Which one will be discharged? Copper is less than hydrogen, right? So copper will be discharged. We migrate to the cathode. The copper ion will migrate to the cathode. Right? So between SO4 and OH, which one will migrate to the anode? The OH, right? Okay, so this is what is happening here. Here is the labeling. This is the negative electrode. This is the test tube. We use the test tube to cover, like isolate them, cover them here. And then this is the positive electrode. Positive because it's connected to the positive side of the battery. This is negative because it's connected to the negative side of the battery. Okay. This is a beaker where you have the electrolytes. This is the electrolyte that dissociates when electricity passes through it. It breaks down into 4 ions. Okay. Now, here, product at the cathode. Copper ions and hydrogen ions will both be attracted to the cathode, but the less reactive one will be discharged. Which one is the less reactive one?
Copper.
The copper. So it's the one that finally, they will both be attracted, but the one that will be discharged or migrate properly to it is the copper. So in this case, copper is less reactive than hydrogen. So copper will be totally migrated around the negative negative electrode, which is the cathode. Copper negative electrode. Yeah. Okay, this is the negative electrode. So copper will be discharged here, or will migrate here. They will both be around, they will both be around. But the one that will now bubble around here, or bubble into this test tube, is the copper. Okay, so in this case, a metal will be produced at the cathode. So copper ions are discharged at the cathode, and then they will what? They will gain electrons and they will be reduced to form copper metal. When they gain electron, the copper ions gain electron, become a copper metal. Then the half equation is this one. This is the equation at the cathode. Copper ion plus 2 electrons become a copper as a metal. Become a copper as a metal. Now let's take a look at the product at the anode. Let's take a look at the product at the anode. Now we say the SO4 ions, the sulfate ion and the OH ion, hydrogen ions, are both attracted to the anode, but remember we say it is this one that will totally migrate into the anode. So OH ion lose electron more readily than this. So OH ion lose electron and be oxidized to form oxygen. They lose electron and be oxidized to form oxygen gas at the anode. Here is the half equation. 4, okay. Okay, so this one, we lose electron to form oxygen gas, water, and this ion. So this is what happens. It loses electron to form oxygen gas and then water. So this is what happens at the anode. This is the equation at the anode. Is that okay? So now here, so you need to know how to write this half equation, write this equation at the cathode and this equation at the anode. Here is the proper circuit diagram. Okay. Now here is when we are using a different electrode. Now we're using copper electrode. The first case we are not using copper electrode, we are using maybe carbon or graphite. Okay. But this case now, we are changing this electrode to something else. We are using copper now. We are using copper electrode. Imagine you are doing electronics of copper and you are also using copper as electrode. So the story will definitely change. See, copper anode, copper cathode. Then here we put a variable resistor to vary the current so that we can regulate the amount of current that we want. Then here we have a direct current. Here we have an ammeter to measure the amount of current that is flowing here. Here we have aqueous copper 2 sulfate. This is the solution we want to electrolyze. We want to break it to ion. Electrolysis is simply passing electricity through a compound or electrolyte to break it into ions that will eventually migrate to the anode and the cathode so that we form a new product. That's the whole essence of electrolysis. So if you take a look at this, you observe some things. Let's take a look at some of the observations that may come from the fact that we are using copper in both anode and cathode, and also our electrolyte is also aqueous copper 2 sulfate. So some of the observation is that the copper increases in mass while the anode decreases. Sorry, the cathode decreases. This one will swell up. This diagram really shows that conspicuously. This one will increase in mass. Okay. The cathode will increase in mass, while this one, the anode will decrease in mass. We have an explanation for that. Now this occurs as copper atoms are oxidized at the anode and they form ions, while copper is reduced at the cathode to form copper atoms. So copper is reduced here and is oxidized here. Copper is reduced at the cathode, okay, but is oxidized at the anode. So if you look at the equation of cathode and anode, we say copper is oxidized at the anode, right? Right? We say this occurs as copper atoms are oxidized at the anode. So at the anode, the copper are oxidized. Okay, this is like oxidation reaction. And then here they are reduced to copper. So there's more mass here at the cathode than at the anode. The gain in mass by the negative electrode is the same as the loss in mass by the positive electrode. So whatever is gained here is what is lost here actually. You lose some mass, then it's added up here. Therefore, copper deposited on the negative electrode must be same copper ions that are lost from the positive electrode. So whatever copper that is deposited here must be the copper that is lost from here, because whatever is gained here is what is lost here. Is that okay? Now, what this means is that the concentration of copper ions in the solution remain constant. The concentration of copper ions here will be constant, because whatever is lost here is what is gained here. Now, let's take a look at the product form for the common aqueous solutions, the different ones that we have looked at. For concentrated sodium chloride, this is not brine, okay? For concentrated sodium chloride, chlorine is produced, is released at the anode, and hydrogen is released at the cathode. Now for dilute sodium chloride, oxygen is produced. You know, remember we say once it's dilute, the anode will be oxygen. Once it's concentrated, the halide will migrate to the anode. So for dilute one, oxygen is produced and hydrogen is still produced at the cathode. Now consider concentrated aqueous copper 2 sulfate. Oxygen is gas is released or is produced here. Okay, because we say concentrated aqueous, meaning it's still mixed with water. Still mixed with water, is diluted, despite because it's not so concentrated. So oxygen gas is released, and then for the cathode, product at the cathode, copper is definitely lower than hydrogen, so copper is produced, right? It's preferably discharged as the metal. Now dilute sulfuric acid, once it's dilute, whatever is produced at the anode is oxygen. Oxygen gas is produced, then hydrogen is produced at the cathode. Okay, so I think we stop here. Next class we will let's see where we are going next one. Ionic half equation. That's what we're going to take.
Just write the number 4.1.5.
Yeah, that's where we stop. 4.14 is where we stop. Next one is 4.15.
This page, guys. 4.15, right?